some useful definitions. Number 1, the absolute value of a real number x is denoted by mod x or maximum of x comma minus x. And defined as mod x is equal to x if x greater than 0, minus x if x less than 0, 0 if x is equal to 0. So mod is always a positive quantity. X is real number, means 0 number, positive number, negative number, anything. So, sir, you told, and we know modulus of any number is a positive quantity. But in the middle case, minus x, it seems that negative, but it is not negative. See, some condition I mentioned, when x less than 0, the number itself is negative. For example, take minus 2. What is mod minus 2? Minus into minus 2, minus into minus plus. Finally, it becomes plus quantity or not. Mod minus 2, we know that plus 2 or not. That is mod 0 value. When x equal to 0, mod 0 value 0. Okay? See, look at the graph. Graph of f of x is equal to mod x. X-axis, y-axis. You know how to draw the graph. Take randomly some x values, find the corresponding y values, that is mod x values, plot these points in a 2D graph, join these points by a smooth curve, which we have learned from our childhood class 8th, 9th, 10th class. So, you will get V-shaped graph. So, this is symmetrical about y-axis. So, when a curve equally lies in areas for first comma second quadrant or third comma fourth quadrants, that curve is called symmetrical about y-axis. When a curve equally lies with respect to areas in first comma third quadrant or second comma fourth quadrant, opposite quadrant, that curve is symmetrical about origin. Okay? So this is origin 0 comma 0. So what is this blue color graph? This right hand side blue color line is plus x, and the left hand side blue color line is minus x, and this point is 0. That is the meaning. Okay. So this is and this is fx is equal to plus x, y is equal to x, straight line passing through origin. This is fx is equal to minus x. So it makes an angle 45 degrees. This blue color straight line makes an angle with x-axis 135 degrees. So that's why slope of this line is plus 1, slope of this line is minus 1. That is geometry from 10th class, 11th class. Okay. So what is the geometrical meaning of, why should I take this graph? What is the geometrical meaning of a function f of x, that is a curve is continuous in a given interval or for the given x values? What is the geometrical meaning of derivative of a function? So, if the graph of fx drawn without breakings, that function graph is called continuous at every x. So, this is the blue color graph is the graph of mod x. Here it is no breaking. So this mod x is continuous at every real number. That is the geometrical meaning of continuity. But graphs are not easy. for some x terms. It takes more time or difficult also. There is a problematic approach for finding or proving a function f of x is continuous at a point, similarly differentiable at a point. One by one we will discuss. That is 11th class procedures only. Okay. Now, when do we say that a function is differentiable? Once it is continuous. The compulsory condition to say differentiably, the function must be continuous. On the curve, at every point, there will be a unique tangent. There will be a one tangent only. So, what is the meaning of tangent? A line touches the curve at a point. That is called geometry. Okay. So, this blue color line, which is the curve mod x. At every point on this blue color straight lines, how many tangents you can draw? Only one tangent. That means the curve itself is a tangent at each point on that line. So, at every point on this line is differentiable. What can you say about at 0? At 0, x-axis touching, y-axis touching, this blue color line touching, this is also touching. Okay. So, that means mod x, this graph, is differentiable at every point, at every real number, except at x equal to 0. This is asked 3 to 4 times in GATE, 1 mark. Okay. It is useful in some problems also. Implies f of x is equal to mod x is differentiable at every x except at x equal to 0. Okay. That is, mod x is not differentiable at x is equal to 0. 0 means origin. Now, other values of x, that is d by dx of mod x, that is derivative with respect to x, is given by mod x by x if x not equal to 0. For example, not equal to 0 means greater than 0, less than 0. When x greater than 0, mod x value x cancelled, you will be getting 1. Slope of this side straight line, blue color straight line is 1 only. When x less than 0, mod x becomes minus x. X cancel will give minus 1. Slope of this blue color line is 90 degrees plus 45. That is tan 135 is minus 1. Okay. So you compare with the derivative analytical procedure and with coordinate geometry procedure also. That is. Slope means m. M is denoted by tan theta, where theta is the inclination of the line with positive x-axis. That is in advanced level, that is dy by dx. So in coordinate geometry, slope of a straight line joining 2 points is also same by this method only. y2 minus y1 by x2 minus x1. 1 by 1 connecting topics only. Okay. Next, every differentiable function is continuous. Every differentiable function is continuous, but converse need not be true. What is the meaning converse need not be true? Suppose x square function, it is a parabola, upward parabola. X square derivative exists 2x. So x square is differentiable at every real number. The same x square is also continuous. Okay. Now take mod x. Mod x is continuous at 0. No breakings at 0. But mod x is not differentiable at 0. So that's why every continuous function may or may not be differentiable at that point x. Take care. Next, some useful results I am writing here, which are useful in probability chapter. Mod x less than a real number L implies and implied by minus L less than x less than L. Okay. Similarly, mod x greater than L implies and implied by, suppose you have, while solving problem, the last step, if you reach like this, mod x less than mod x greater than, which is not in ABCD options, then you consider this type of answers. My x less than minus L, comma, x greater than L, where L is any number. So, suppose take L is equal to 2. What is mod x less than 2? You have to find all values of x where after taking modulus that should be less than 2. What is mod x greater than 2? If I take L is equal to 2, you have to find all values of x satisfying this. That is this answer. Okay. This is the first definition. Please go ahead. Where I am putting the tick, that is very, very important. Definition number 2. This is read as some people box x or bracket x or square bracket x, integer part of x. Okay. Is called the integer part of x or step function. The graph looks like staircase, step function. Fx is equal to box x or bracket x. And defined as box x is equal to the greatest integer which is less than or equal to this x. In mathematical symbols, that verbal language can be written as less than or equal to x. So take any number. What is this bracket x, integer part of x? Find all integers which is left side to x. Take x, take a number, that is x is equal to some number. You have to find all left side integers. Less than means left side, I told you long back. Greater than means right side. Find all left integers. One of these is highest, that is called greatest. That value is called bracket x function. Okay, see. Example, bracket 0 is equal to 0. Bracket 0.23, this is also 0. So on, bracket 0.999 is also 1. So in this case, this is x value 0. 0.23 x, 0.99, this is x. So, for example, see, this is the number line. 0, 1, -1, -2, 2. So, 0.99 means this is almost this position 0.999. Okay. So, for this is called x. For this x, what are less than integers? That is left side integers 0, -1, -2, etc. Of all these, the greatest is 0. That is bracket 0.99 is 0. Okay. So that means box x or bracket x is equal to 0 if x is equal to 0, greater than or equal to 0, almost 1, less than 1 only. So when 0, 0, 1 in your real number diagram is two consecutive integers, the left integer is the answer. Bracket x is simply easy to remember. Similarly, see, bracket 1, box x 1, bracket 1.5, this is also 1, so on, bracket 1.97, this is also 1. In this case, this one is x, 1.5 is x, this is 1. So just like you draw the number line, you can cross check. Implies bracket x is equal to 1. Which values of x? 1, greater than 1, less than 2. So the answer is left integer. So in this case, final generalization, bracket x is equal to n if n less than or equal to x less than n plus 1. This is when x values lies between two consecutive integers. What is the meaning of consecutive integers? Side by side, 0, 1, 1, 2, 2, 3, minus 1, 0, minus 2, minus 1. For that x values taking, that bracket x is nothing but left side integer answer. Okay. If you draw the graph, I will give that directly. Staircase graph only this is continuous as well as differentiable at non-integers only. Take care. What is non-integers means? Fractions, rational numbers, irrational numbers, everything. At integers, it is discontinuous as well as not differentiable. Now, some standard functions I am giving continuous as well as differentiable, which are helpful in the coming subtopics of calculus. All these are 11th class, 12th standard basics. Fx is equal to constant, okay, comma, x power m, polynomial function, okay, comma, e power x, sin x, cos x, sin hx, cos hx. What is sin hx, cos hx? Hyperbolic functions. In terms of exponential, how much? E power x minus e power minus x by 2. In this, e power x plus e power minus x by 2. All these are without graph and without procedure. You can say continuous as well as differentiable. Continuous as well as differentiable. At every real number x in this case m is equal to 1, 2, 3, polynomial function. So when two functions are continuous as well as differentiable, their addition, their sum, their difference, their product, their quotient are also continuous as well as differentiable, provided denominator not equal to 0. Okay, please remember that. If fx comma gx are two continuous slash differentiable functions in the interval I, then what is interval I means? Either open brackets, open interval, or closed interval, or set of all numbers, real numbers, anything. Then fx plus gx, f of x minus g of x, f of x into g of x, and f of x divided by g of x is also continuous slash differentiable at every x belongs to I. At every x belongs to means I is an interval. It is containing so many numbers, each number denoted by x. So difference, addition, multiplication, quotient are also continuous as well as differentiable. In this case, denominator not equal to 0. Take care. And some other 11th class equation of the tangent, equation of the normal 1 or 2 times for mechanical stream ask. These points, sometimes they will test your knowledge, how much of you remembered that 11th, 10th class basics also. It's a rare case only. Number 5. Equation of the tangent to the curve y is equal to f of x at a point P x1 comma y1 is tangent means straight line. Straight line 1 point form passing through 1 point in coordinate geometry 11th class. Y minus y1 is equal to m into x minus x1. Where m is equal to dy by dx at P. You know how to calculate for this equation dy by dx, differentiate with respect to x. And then substitute the point in place of x, x1, in place of y, y1. That is called slope of this. Is the slope tangent from 11th class geometry, coordinate geometry. Equation of the normal at Px1 comma y1 to the curve y is equal to fx is y minus y1 is equal to minus 1 by m into x minus x1. You know that product of the perpendicular line slopes is slopes of the perpendicular lines. Product of the slopes for perpendicular lines is always minus 1. m1 into mt is equal to minus 1. Tangent is always perpendicular to normal. Normal is perpendicular to tangent. Okay. Now, 6th point. When you have two curves intersecting at a point, at that point an angle theta is formed. What is the theta? That is the angle between two curves at the point of intersection Px1, y1 is given by, which is asked in 2016. Okay. Let theta be the angle between two curves y is equal to f of x, or this curve equation can be expressed all terms in the left side, which is denoted by phi of x comma y is equal to constant, and another curve equation y is equal to g of x. This curve equation can be expressed as some another function of x comma y is equal to constant, that is psi of x comma y is equal to some constant 2, here constant 1, equation 1, equation 2, at a point of intersection P, then tan theta is equal to m1 minus m2 divided by 1 plus m1 into m2. Okay. If they ask acute angle, take modulus on the right side. Acute angle means the angle which is in the first quadrant less than 90 degrees. What is this m1, m2? Where m1 is equal to slope of the tangent, that is dy by dx at P. m2 is equal to slope of the tangent, that is derivative at P, is slope of first curve, that is equation 1. This is slope of second curve. Slope of the tangent only. Slope of the curve means automatically it is asking slope of the tangent to the curve. Equation 2. Okay. Now you know that physics, that is when it is a displacement or speed, whatever it may be, distance is given, that is denoted by capital S. Velocity is first derivative, acceleration is second derivative. That means if the displacement s is with respect to a time variable t, ds by dt is called velocity, d square s by dt square acceleration. When that displacement is expressed in two variables x comma y, so velocity is dx by dt, dy by dt. Acceleration is d square x by dt square, d square y by dt square. When the equation of the curve, that is displacement s, is expressed as a 3D geometry, three variables, x, y, z, then velocity is dx by dt, dy by dt, dz by dt. All x, y, z are with respect to time t. Acceleration is d square x by dt square, d square y by dt square, d square z by dt square. These are basics from 11th class only. Okay, so that is easy to understand, remember. And while going to do one by one topic, you should remember simple derivatives and simple trigonometric relations, simple coordinate geometry equations also. Okay. So I am providing just simple derivatives, standard, derivatives of standard examples or standard functions. FNS means function. D by dx. How to pronounce in verbal language? Derivative with respect to x. Constant, 0. This is constant. Constant derivative is 0. Only d. D stands for derivative. D by dx stands for derivative with respect to x. Next. D by dx of x power n is equal to n into x power n minus 1. D by dx of ln x. Natural logarithm, basic logarithm, that is 1 by x. D by dx of e power ax. A into e power ax. A is constant. D by dx of a power x. A is base is constant. A power x into log a. Here power a is constant. Here base is constant. Next, d by dx of sin x is equal to cos x. D by dx of cos x is equal to minus sin x. D by dx of tan x is equal to sec square x. Some people pronounce it as secant square x. D by dx of cot x minus cosec square x or cosecant square x. Minus cosecant square x. D by dx of tan inverse x 1 by 1 plus x square. D by dx of sin inverse x 1 by root over 1 minus x square. Next, d by dx of uv is equal to v into u dash plus u into v dash, product rule, and d by dx of u by v, v into u dash minus u into v dash by v square. Please by heart all this. And in simplifying some problems, you remember some trigonometry, sine 0, sine 180, sine pi by 2, all these things. 2 sine square a, 2 sine a cos a, 2 cos square a, these formulas. So sine 0, 0, cos 0, 1, sine 90, 1, cos 90, 0, tan is equal to sine by cos. These are 10th class basics. Okay. To 2 sin a cos a is sin 2a. 2 sin square a is equal to 1 minus cos 2a. 2 cos square a is equal to 1 plus cos 2a. These are the formulas. Sin 30 1 by 2. Cos 60 also 1 by 2. Sin 60 root 3 by 2. Cos 30 also root 3 by 2. Sin 45 is equal to cos 45 is equal to 1 by root 2, etc. These are the basics which are helpful in substituting the limits in integration chapter. And straight line equation, parabola equation, ellipse equation and circle equation you have to remember, which are helpful in max 2 subject as well as some problems in calculus, that curves also. That is coordinate geometry. So now I am going to start limits problems, limits how to find in different ways, in different situations of the problems. So first of all, what I am explaining, suppose limit is denoted by LT. X tends to A, f of x. What does it mean? When x approaches to A, that is also called x tends to A. A is fixed number, x is a variable tending to almost A. Then f of x approaches to how much? That is called given by limit concept. Okay. So, for example, the question is limit x tends to 0. X plus 1 by e power x. This is the question. So, just to, in problematic approach, if x tends to 0, in this function, in place of x put 0. That is, put x equal to 0, provided the answer is exist. If you are not getting exist, then that type of limits problems useful obtained by standard limits. Just like standard derivatives, there are standard limits which are considered as formulas. If the given problem is not also, is not obtained by, that means the value of the given limit is not obtained by directly substituting here or by standard limits procedure, then it is obtained from 0 by 0, infinity by infinity, that is indeterminate forms. These are the 3 ways for a given problem. Not 3 ways. There are, for a given problem, any one of these 3 methods applicable, or sometimes 2 methods applicable, sometimes 3 methods also applicable. Standard limits. That means standard limits means some limits are there which are considered as formulas. 1. Limit x tends to A, x power n minus a power n by x minus a is equal to n into a power n minus 1. N is a rational number. Okay. Number 2. Limit x tends to 0, e power ax minus 1 by x or sin ax by x or cos ax by x all are equal to a. Number 3. A is a constant. Limit x tends to 0, a power x minus 1 by x is equal to log a. That is natural logarithm. Or you can write log a to the base e also. Number 4. Limit x tends to infinity, log x by x or sin ax by x, or instead of 3 formulas I have considered all the 3 results in one formula only. Cos ax by x is equal to 0, where a is a constant. Number 5. Limit x tends to 0, 1 plus a into x whole power b by x is same as limit x tends to infinity, 1 plus a by x whole power bx is equal to e power ab. 6. Limit x tends to 0, 1 minus cos ax by x square is equal to a square by 2. And the last one, not asked so far, but I am considered as a formula, x tends to infinity, x power 1 by x is equal to 1. N, A, B are all constants. The quotients can be represented by limit symbol LT or LIM also. Any one of these they can give. And just a note, please by heart all the 7 formulas. So far the questions asked directly this one, this one, and this is only this remaining or one time. Many problems related to this only. Limit x tends to a constant k is equal to k. Derivative of constant is 0, but limit of a constant is itself. Next, limit x tends to a sum of two functions or difference of two functions is nothing but sum of their limits. Term by term you can find limit of x plus or minus limit g of x. Limit x tends to a fx into gx. Limit of product of functions is equal to product of their limits. Limit x tends to a f of x into limit x tends to a g of x. And finally, limit of quotient of two functions fx by g of x is equal to limit x tends to a f of x divided by limit x tends to a g of x, provided denominator not equal to 0. Similarly, limit fx power gx, you can apply base limit as well as power limit also, provided each is exist. So please by heart all this. So I will do 2 to 3 problems using this later. Let me tell one more observation, that is indeterminate forms. How to overcome, to evaluate when a limit is become indeterminate form. That is important, that type of problems. Using formulas everyone can do. Some problems directly by comparing these 1 to 7 formulas, one step answer. Otherwise, some adjustments, adding, subtracting, multiplying, dividing, and finally we'll get our limit comparing with one of these formulas. That problems everyone can do easily, okay? But indeterminate forms limits are important. Note. Zero by zero, infinity by infinity, comma, 0 into infinity, comma, infinity minus infinity, comma, 0 power 0, infinity, 1 power infinity, and infinity power 0 are called indeterminate forms. That means, indeterminate means it cannot be determined, infinite solutions you can also compare. For the first 2 forms are very, very important. So, what exactly that 0 by 0, infinity by infinity. And these 3 forms having same procedure, and this just one step on, extra 1 or 2 steps procedure will finally becomes 0 by 0, infinity by infinity. So I am going to explain what is the meaning of 0 by 0, infinity by infinity. If limit x tends to a, f of x divided by g of x is 0 by 0 or infinity by infinity. So just limit fx by gx, how I told? Limit fx divided by limit gx. When numerator 0, denominator 0. Similarly, when numerator infinity, denominator infinity. Both are 0, both are infinity. Then limit x tends to a, f of x divided by g of x. This is question. Now answer is limit x tends to a, f dash x. F dash x means derivative of f of x divided by g dash x, derivative of g of x with respect to x. Okay, provided this should be exist. Okay, this is called L Hospital's rule, 11th class. Take care. While finding limit of quotient of two extremes, two functions, if both numerator denominator 0 0, infinity infinity, then what to do? Derivative to the numerator f of x, derivative to the denominator g of x with respect to x. So find derivative to both numerator and denominator with respect to x, that is f dash x, g dash x. Find that limit for that obtained function. If that is exist, then this is applicable. This is called L Hospital rule, invented for this procedure. Later I will discuss one by one other forms with one example each in the next session. So all of you have a take a break.